This is video 721, and the goal of this is to solve systems of equations with three variables. So we're looking at systems with two variables, x and y, typically, but now we're going to look at systems with three variables, x, y, and z. So the first thing you need to understand is what is it exactly that we're finding. The equations will look like the following: ax plus by plus cd equals d. Okay, so there's no quadratic involved here. We're simply looking for, this is actually a plane. When we describe with three variables, x, y, and z, that's actually a plane that has a left and a right direction. X and y are going, left and right is x, up and down is y, and then forward towards us in the third dimension is your z value. And so we're literally looking for a point of intersection. We're still looking for that point of intersection, but in this case it'll be three planes because we'll have three equations like this, three planes, three variables, and we will be looking for where those three variables, those three planes intersect. Now let's take a look at how to do that, because we're not going to use substitution anymore because that's going to take way too long. First of all, so we're going to show that the ordered triple is a solution of the system. Okay? It may not be the only solution, and we'll talk more about that in the next video, but show that it is a solution of the system. So simple way to do that is simply plug it in. So we're going to do 1 minus 3 times 0 plus 2 and check that it equals 3. Because remember, this is of course x, y, z. And so I do the math here, and it looks like I get negative 2 plus 2, which does not equal 3. So my answer is no, it isn't a solution. Because it should work in the equation. Let's take a look at the next example. So now we're going to solve this system. So let's talk through the steps to do that because it is a little bit harder than you might imagine. We're going to solve the system by doing elimination. But the keys with elimination are we need to use an equation to eliminate one variable from the other equations, because we need to break this down into two equations, two variables, and then we'll break it down into one equation, one variable. So we just have one additional step beyond what we used to do with our two variable systems. So first of all, hopefully you notice that if you merge these two equations, your z's are going to make a 0. They're going to eliminate. So that's our first step. We're going to add those two together. When I do that, I'm going to add 5x minus 3y plus z, and I'm going to add 2x minus y minus z to it. And let's see what happens. I'm going to get negative 1 on the left. I'm going to get 0 here. I'm going to get negative 4y and 7x. So now I have an equation, 7x minus 4y equals negative 1. I have an equation in two variables using the top two equations. So now I need to eliminate the same variable z from the other equation, this equation. Otherwise, I got to include all three equations here. But again, it doesn't matter which one I merge with this, but I need to do it in such a way that I eliminate z. So since there are 5 z's, I need the other equation to have negative 5 z's in order for the z's to eliminate. Well, if I look at this equation and I simply times it by 5, I will get exactly what I want. So that's what I'm going to do. I'm going to time that equation by 5 so that the z's will eliminate. I'll add these two equations together just like I did with the other one to eliminate the z's. I'll get 11x's minus 7y's equals negative 3. So now I have two equations with two variables, and it's back to basics. Now I have two equations with two variables. I simply solve them the way I know how from the past. So my two equations, 11x minus 7y equals negative 3. My other equation is 7x minus 4y equals negative 1. So now I'm going to take this equation and I'm going to solve for x and y. That's it. It's back to basics, back to what we did in class yesterday. So I think elimination typically is our best strategy. Honestly, it won't matter in this case. So how about I times the top equation by negative 7, so I get negative 77x's. And I'll times the bottom one by positive 11, so I can get positive 77x. So let's see what happens when I do that here. Negative 77x plus 49y equals 21. and the other one will give me 77x's minus 44y's equals negative 11. Now I'm ready to merge these two equations and eliminate x. X will go away. I'll end up with 5y's, and that equals positive 10. One more step to get y alone. Y is 2. So I found my first variable. Now I go back and I work my way backwards and I solve for x and z. I'm first going to start by solving for x, and I'm simply going to plug in this variable into I'm going to plug this variable into one of the equations that I had in black here. So let's just use this one. 11x minus 7y equals negative 3. I'm going to plug in 2 for y to find my x. So just like normal, this should all be very familiar from what you've seen in the past with systems. Solving for x, I'm going to get 11x equals 11, and I'm going to get x is 1. So I've got 2 of my 3 variables. Last but not least, I'm going to solve for z, of course, and I'm going to plug in the point that I already have, 1, 2, comma, something. I'm looking for z. So I'm always going to go back to my original equations. You don't want to use the ones that you've altered, meaning the ones that you've multiplied by something. So we don't want to use any of these equations. We want to use one of the original equations listed here. So we'll just take the top one. We're going to have 5x minus 3y plus z equals 2. Plugging in x and y, we get 5 times 1, 3 times 2, plus z equals 2. Don't forget that's a z, so be careful with your z's. They look like 2 sometimes. 5 minus 6 plus z equals 2. And I'm going to get, for z, looks like I'm going to get 3. Ironic. 1, 2, 3 is the solution. Now, it's always a good idea because there's so much calculation going on here. It's always a really great idea to check your answer. So, simple check of your answer, I'm going to take maybe one of the other equations. I just used the first equation to find z. So let's try the other equation. Let's plug in my 1, my 2, and my 3, and make sure that I, in fact, get negative 3 like I'm supposed to. And in doing that, I will get, this will go away, and I will get negative 3. And therefore, I know that my solution works for 2 of my equations. I could check it in the third as well to be extra sure on a test. But the solution to the system is 1, 2, 3. Let's take a look at one application problem that you're going to see, and we've actually already sort of been doing, but we've had some slightly different situations. Let's take a look. In a study relating sleep and death rate, the following data were obtained. Use the function y equals ax squared plus bx plus c to model the data. So they're telling us that this is probably going to be a quadratic. And so remember, this is your xy pairs. And we want to model the data. So we're trying to write a rule to model this data. So we're going to plug in our points x and y in for x and y and make 3 equations with a, b, and c being our unknowns. We don't know the equation a, b, c. Just like in will it hit the hoop. So we're going to plug in x and y. So 1,682 for y. And then we have a times 4 squared plus b times 4 plus c. Now I'm going to quickly rewrite this in what is more standard form. 1,682 equals 16a 4b plus c. So that's my first equation when I plug in x and y. I'm going to do the same thing with the next x and y pair. So I'm going to get 626 equals, let's see, 7 squared is 49a plus 7b plus c. And last but not least, we'll plug in for my third and final point, 967 equals 9 squared, so 81a plus 9b plus c. So now my 3 variable system, with a, b, and c being the unknowns, and I'm going to now solve for a, b, and c. Find the rule for this data. So in order to do that, I'm going to need to start with eliminating a variable. And I noticed that all the c's are 1. There's all 1 c for all 3 of these. So I think c is going to be my easiest variable to eliminate. How about if I take the first equation and times it by negative 1? So everything's negative. And then I'll have an equation that will eliminate with the other 2. So let's add it to the second equation, 626, 49a, 7b, and c. Adding these two together, the c's will go away, which is the whole goal. I'm going to get. So of course, combining these, the c's become a 0, and I'm going to get 3 b's, 33 a's, and on the left-hand side, 1,056. So that's one of my equations that I'm going to use to eliminate a second variable. So I'm going to copy that over here for now and have it ready. Now we're going to do the same thing, but now we're going to take, of course, this one that we turned negative, and we're going to combine it with the bottom equation, because of course we need to incorporate that one into the mix. I'm going to put the bottom equation as well, so 967, 81a, 9b, c. Merging these two together, I get 715, oh, that should be negative, equals, oh, and this should be negative as well, I think I forgot that earlier. And then 81 and 16 would make 65 A's, and these are all positive, and 5 B's. So hopefully you're noticing that even I'm going to make quite a few mistakes here, because it is lots of little calculations, and you got to be extra careful and cognizant. Otherwise, you'll make silly mistakes. Now, one thing I notice, I'm going to copy this equation over, and as I'm copying this, I notice a couple of things. I notice that everything is divisible by 5. And I think of that as a great opportunity. If I divide everything by 5, that's a legal move, just like timesing. I'm really timesing by 1/5 when I'm dividing by 5. I will get a b that's 1, and I know that's going to help me eliminate. Now I look at the top one and I think, maybe I can do that up there as well. So this is kind of just a neat strategy. You don't have to do this, but your numbers are going to get increasingly larger as you times by things. I see the top one is divisible by 3, I believe. 1,056 is the only one I could be unsure of. Checking it out, I get 352, so it does work. But I'm actually going to divide it by -3, because that's going to give me some numbers that are smaller and easier to manage, and it's also going to just ensure I have a little bit less errors in the long run. So dividing the top one by -3, I'm going to get -352. Oh, I'm sorry. Remember the 1,056 was negative? So I'm going to get +352. See, all these little silly errors. I'm going to get -11a and -b, excuse me, because I'm dividing it by 3. And I'm going to do the same thing with the bottom, but now, of course, I'm dividing by +5. So 715 divided by +5 is 143, and that's now still negative because I'm dividing by positive. And dividing 65, I get 13 A's and 1 B. Now I have two equations. These are identical to the one right above them. I haven't merged anything, but now I can eliminate much more efficiently because my B's are ready to be gone. My A's merge to 2 A's, and on the left side, 352 and -143 make 209. One last step, I'm going to divide both sides by 2, and I get A equals 104.5. So I already have one variable. I have my A value. I do need to find my B value. So of course that means I'm going to plug things in. I'm probably going to just plug it into one of these equations here because they're the simplest and they're equivalent to the ones above them. So 13 times 104.5 plus B. Solve this equation for B. And I'm going to get 358.5 plus B. I'll write that a little nicer for you. So 1,358.5 plus B. Subtracting that from both sides, I get a negative 1,501.5 equals B. So notice I have my A and my B value. Now I'm ready to go and plug things into my original equations. Let's go back to that and see what my original equations were. So I'm going to go back to, it honestly won't matter. So you can pick the one with the smallest numbers, or I can pick this one because it doesn't really matter. I'm going to just plug it in, and I'm going to find, plugging in my A, so 16 times 104.5, and 4 times negative 1,501.5 plus C. And And now I'm going to solve for C, of course. Doing these calculations of 16 times 104.5 plus 4 times negative 1,501.5, you will end up seeing that you will get negative 4,334 plus C equals 1,682. Adding that to both sides, I'll get C equals 6,016. So I have my A, B, and my C values. I am ready to write the rule. I could double check my A, B, and C by checking them in my other equations and plugging them into, for instance, the second equation and making sure it actually gives me 626. But the answer to this question is not just what are A, B, and C. It said use the function to model the data. So we're trying to write a rule to model the data. So my rule is now plugging in my A, B's, and C's. 104.5 x squared. And then B is negative 1501.5x and plus C. That's the answer. So just like we were modeling the basketball shooting problem by writing a rule and then answering some questions about it, same thing with the sleep study. So here's your free response questions, your questions for your checkpoints. You're trying to solve the system, and I'm going to give you one quick hint on that one, so let me show you this a little more carefully. I would recommend using the second equation to eliminate, or you could use the top equation. It doesn't really matter, but try the elimination method. And then the free response question, explain how you show that the ordered triple is a solution. I really want to hesitate on the multiple choice because do not just use the answers to guess and check, meaning it's a great strategy on a multiple choice test, but right now you're trying to see if you can do this. Don't just plug this in and make sure that it works, and then try the next one, because that's really not doing much math, okay? So that's actually what free response question is asking. Show that the ordered triple is a solution. I gave the other one to you as a multiple choice purely so that you could know if you got it right or wrong, if you got stuck or not. So good luck, bring those questions in, try your best, and thanks for watching.